Here I have an example of a piecewise function that breaks off when x is 2. Alright, so when x is less than 2, I have the red function. When x is greater than or equal to 2, I have the blue function. So now even though x is not equal to 2 for the red function, I'm going to plug it in anyway just to see where it ends. So if you plug in 2 to the red function, you get -4 plus 3 or -1. So we're going to go 2 over and get -1. And I'm going to put an open dot because it's not actually part of this function. And let's see, it's a linear equation, so my intercept is 3, so it's going to go through here. And so the graph of this piece is going to look like that. The second piece of the function is a quadratic. And I'll make sure I do that in blue here. And I can read the vertex right off of this. And some people like to remember it as change keep as far as the signs go. So even though it says -5, I'm going to make it a +5 for the vertex. And then keep the sign on the outside number. So I need to plot the coordinate 5, 2. So 1, 2, 3, 4, 5, 2. Okay. And when I plug in 2 into the blue function, I will get 2 minus 5, -3. -3 squared is a +9, but there's a negative out front, so -9 plus 2 is -7. So 2, -7. 1, 2, 3, 4, 5, 6, 7. So that's going to be right here. And it's going to be a closed circle because it is equal for 2 on that part of the function. And since this is a parabola, and I did my vertex, which is over here, my vertex sits on a line of what's called a line of symmetry. So for this point here, since it's 3 units away from the axis of symmetry, I need another point 3 units away. Okay, so just to sketch this part of the graph, it's going to look something like this. Alright, and so together that makes up the entire graph for f of x.